Hello all, this is Anita. Welcome to the machine learning video lecture series. In this video, we will understand the post-pruning and pre-pruning techniques in the decision tree. So let's get started. So to understand the post-pruning and pre-pruning, first we need to understand what is overfitting. So overfitting is the common problem that needs to be handled while training a decision tree model. So in decision tree, in order to fit the data, the model keeps generating the new node and ultimately the tree becomes too complex to interpret. So this is overfitted model. Here, overfitting occurs when the model fits too closely to the training data and may become less accurate when encountering the new data or predicting the future outcomes. So decision tree are prone to the overfitting. So decision tree will always overfit the training data if we allow it to grow to its maximum depth. So to overcome the overfitting problem of the decision tree, we will be using the pruning technique. So first, we need to understand what is pruning. So pruning is a in decision tree is a technique that removes the part of the decision tree and prevent it from growing to its full depth. So pruning remove those part of the decision tree that do not have the power to classify the instances or that have the less information. So that we are removing. So there are the two techniques in the pruning, the pre-pruning and the post-pruning. So we will understand one by one these two techniques. The first one is the pre-pruning. So this technique is used before construction of the decision tree. So this is the process of early stopping the tree growing process before it reaches to the maximum depth. The tree is stopped from growing by setting a stopping condition. So here we will understand this with the help of example. So consider based on the data set we have generated this type of decision tree and we are saying that this decision tree it leads to the overfitting problem. So this overfitting is more with this type of tree. So how to prevent this? So you can see here when we are reaching at this particular node, so we are having 8 yes and 2 no's, and after splitting this on this node we are getting 8 yes and 0 no, and for this we are getting 0 yes and 2 no's. So here you can see that the ratio of number of yes and number of no. So here number of yes are more than the number of no, and at this point number of yes are more and number of no's are 0. At this point number of yes are 0 and number of no's are 2. So these two are the leaf node, and here you can see the number of yes are more. So when we are getting any sample for the testing, so that time ultimately it is classified into the yes category because we are having the number of yes are more. So here we will be stopping by setting the maximum depth of the tree is equal to 3. So for this from this we will be not splitting. So after this we will be not splitting the tree and we will be preventing the overfitting problem by setting the maximum depth is equal to 3. So here you can see you for this pre-pruning technique we will be setting some parameters like maximum depth. So specify the maximum depth of the tree, minimum sample leaf. It specifies the minimum number of samples required at a leaf node, minimum sample split. It specifies the minimum number of samples required to split an internal node. So this parameter we will be using for applying the pre-pruning technique. Now here you can see this is the default decision tree, or we can say overfitted decision tree on the iris data set. So after applying the pre-pruning technique, we are getting this decision tree with maximum depth is equal to 2. Now the second technique is the post pruning technique. So this technique is used after construction of the decision tree. So it is also called as backward pruning. So it is a technique that eliminates the branches from a completely grown decision tree model to reduce its complexity and the variance. So in this technique, first we are creating the decision tree to its full depth, and then we will be applying the post pruning technique. So here in post pruning technique, the non-significant branches of the model are removed using cost complexity pruning technique, and this function is there in the decision tree escalon. So you can see here on the left hand side the decision tree is before the post pruning, and after post pruning on the right hand side you can see the decision tree is generated after post pruning. Now, what are the advantages of the pre-pruning technique? So, the first one is the simplicity. So, pre-pruning criteria such as maximum depth or the minimum number of sample per leaf are easy to understand and implement. Second one is the computational efficiency. So, by limiting the size of the tree, pre-pruning can substantially reduce the computational cost of the training and the prediction. The third one is the reduced overfitting. So this technique we only use for this reason. Now we will understand the disadvantages of the pre-pruning. So the first one is the underfitting risk. So if the maximum depth is equal to 2 or 3, so then how can we get to know that model reduces the overfitting or converted into the underfitting? So there is no any quantific analysis to measure which direction it will go. No mathematical equation to check the measures. Required fine tuning. So how can we decide which range is right to choose? The pre-pruning parameter like maximum depth, minimum sample leaf often require careful tuning to find the right balance between the underfitting and the overfitting. Now take a pause here and tell me when to apply which technique. After done, resume the video. So here, if our data set is smaller data set, so that time we will be using the post pruning technique. And if the data set is bigger data set, so that time we will be using the pre pruning technique. So while building the decision tree, we will be deciding the applying the pre pruning technique. Now we will understand the issues in the decision tree learning. So the first issue is the overfitting the data. So this overfitting occur when decision tree capture the noise or the random fluctuation in training the data, resulting the model that perform well on the training data set but poorly on the unseen data. So to solve this problem, we will be using the pruning technique. The second one is how you are handling the continuous valued attribute. So decision tree naturally handle the categorical attribute well, but required special treatment for handling the continuous valued attribute. Third, alternate measures for selecting the attribute. So how you are choosing that appropriate attribute selection measure. So here different measures like gain impurity, entropy, information gain can be used to evaluate the quality of the split. So here as a solution we will be choosing the uh, attribute selection measure that maximizes the purity of the resulting subset or minimizes the impurity after the split. The next one is handle the attribute with the different cost. So each in data set, some of the attribute may have a more significant impact on the outcome or may be more costly to measure. So how you are handling such a attribute? The next one, handle the data with the missing attribute value. So in our data set, some of the values or the data is not is missing or not proper. So how you are handling that attribute? So again, there are some technique like uh, fill that missing value, ignoring the instances with the missing value during the splitting, or use the algorithm that can handle the missing value inherently. And the last one is how to improve the computational efficiency. So, constructing the decision tree can be computationally expensive, especially on the large data set. So, what solution you are providing? So, these are the issues in the decision tree learning. Thank you.